Testing. Testing 1, 2. Great. How does the sound, Colt? Too loud? Too silent? Okay, let's go. Okay, if it's okay with everybody, I'm just gonna start now. My name is Mario Ramos, and I work for O'Brien Architects with a little side venture that I have going on called Revit Workshop. And mainly what it is a company to share ideas and help educate others on how to use Revit. And this is in no way the correct way or the way to use it, but oh well. Can you hear me now? Sorry, the workshop is mainly targeted for people at South Plains College, and but I understand that I also have viewers somewhere across the world. So hopefully you can understand, or hopefully are understanding that I will mainly be answering, well, I won't be only answering their questions, but since it's specifically targeted with them, I have to be understanding and mindful of their time as well. Great. So glad I get to start over. My name is Mario Ramos, and I work for O'Brien Architects. We're based out of Dallas, Texas, and we do a ton of projects. We work on multifamily, retail buildings, urban planning, but my specific role is to help draft, and mainly draft in Revit, since this isn't a new software, but not everybody in the US knows how to use it competently, if I want to put it nicely. Um, so my roles varies. I draft, I draw, I manage a couple of projects, and I help teach the rest of the firm how to use Revit. Um, but in doing so, I've realized that there are many other firms, smaller firms actually, that don't know how to use Revit, that don't have the time or money to implement new Revit standards and to train new employees and actually acquire new talent that know how to use Revit. So my goal is to help teach people how to use it. With that being said, this workshop is mainly, again, targeted to South Plains College, and I'm working in conjunction with Colt, an old friend of mine from Texas Tech, but he reached out to me and wanted to see if I could host a workshop for him, and it's mainly a beginner's workshop for him and his college. So what we'll be talking about today is mainly a beginner's course on how to get started, how to start a new project, how to model floors and walls and roofs to the most basic function. We won't cover everything. A lot of what I'll say might make sense to more experienced users, but the goal is at least to help you create the most basic form of a house, which could be a rectangle or a box. Colt actually sent me a project that I think he wants me to share with you guys so that you can model it as well. And I think it's actually your assignment. So whoop-de-doo. So this is the assignment that I think Colt or Nathan is gonna give you guys. It should be pretty fun. It's pretty simple, and I'll talk about how to model it. Let's see what else. And before I actually start showing you how to model all this stuff, I want to share a couple of projects because Revit is very useful, and in the wrong hands it could also be very dangerous. I want to show you the type of projects that you can create. So the first one that I want to show you, which is very related to that project that you'll be working on, is a house. This is a 3-bedroom house, and as you can see, it looks super complicated, but basically this is a construction document view where we'll be will be placed on a sheet where to help our contractors and framers build a house. And let me go to the 3D model view. This is a 3D model. This house actually was built in Lubbock, and it's a huge site. I can't remember the actual acreage, but they're allowed to have horses. So I modeled this house, designed and modeled this house in Revit for a young couple who were planning to move from San Antonio. As you can see, we can get pretty complicated with some of the elements that get involved. So we have all our walls, our roofs, even included. We can see inside that we have ceilings. And before I continue going, just stop me if you experience any lag, or if you have any questions. I'm trying to run multiple things on one screen, and I'm not sure if I'll be missing anything. So back to ceilings. So we have all our ceilings in here. We have other model elements, roof soffits, we have interior lighting, electrical fixtures, doors, and then garage doors, some generic model families that host or attach themselves to other model properties within the house. The other project that I'd like to show you is this is a huge apartment building we're currently working on. And this project is, I can't remember, maybe about 300 units, and it's adaptive reuse. And basically what's going on is the apartments are going on to be constructed along with an old Kroger that's being renovated. So it's kind of like an existing building with new a new addition being attached to it. And in here you can still see the same things go around. We still have our walls, should have our roof. I think it's currently hidden. And we even have our garage and some railings and parking models. Here with multifamily is where it's actually Revit can be a little dangerous in the wrong hands. It takes a certain level or knowledge of constructability practices. So if you know how to build a house, it's basically like learning how to build a house before you build it, because Revit can be a little tricky, and you have to get your construction tolerances, your construction, you just, in the most basic form, you need to know how to build it, because if you model it incorrectly, it can if you model it incorrectly, it can go very dangerously, and you can produce construction documents that could confuse your contractors and your clients, and therefore whenever your framers are actually out there, they could build it very wrong, and it could lead to a very hefty fine or lawsuit. So you have to be careful. And mainly what happens in our firm actually is that we'll have our most experienced Revit users, which I think currently in our office we have about 4 or 5, ranging from experience in building multifamily projects, retail projects, some warehouses, storage facilities, and what's the last one? Oh, and offices, of course, which leads into the next project. So I'm gonna have to close a couple of views just to make sure. So I'm gonna close the Kroger one, and I don't want to save. So the next project I want to share with you is a 10-story office building. This project is actually one that I worked on specifically, and you can see we still have the same thing, but here it gets a little bit different. We have curtain walls, which are actually a type of wall, and they've been collected to become a group so that we can copy them up, and as we change one thing, the change will apply everywhere, and we reduce the amount of drawing and modeling that we have to do. We have our columns, and we also have our walls that vary in depths and heights. This wall is actually an assembly which a precast trade partner will build as a whole unit and deliver to the site in these 2-story spans. So you can model a whole building in Revit, and then you can produce all your construction documents. You'll be able to put those same views that we have on the side, you'll be able to put them on sheets and start annotating, adding all the other text elements, dimensions, notes, and then when it comes to creating sections, which is one I'll show you right now, you can create these really easily, and even if it shows you the most basic cartoon level of a drawing, that's okay, because the point is for you to come in after and start annotating. My personal practice, like my own personal way of building these things, is to build them with as much information as I can to reduce the amount of drawing that I have to do later, and therefore reducing the amount of hours I spend drawing, and then reducing the amount of time that we have to coordinate back with our people, and therefore saving our client maybe some time too. it really all depends too. You need a team as well to help you do this. I didn't do this alone. This is a team effort, and we were able to knock it out in maybe 2-3 months. Let me close this view too, so that way our window's a little cleaner. Nope. And then this is one last project that I'm going to share with you guys. This is a small retail building. This is one I'm currently working on. It is actually a project that I'm managing myself. So I have to draft, model, add all the annotations, create all our wall sections, and deliver a permit set to our client. And there I'm able to create all these views to show where it is in site, show an architectural site plan, and show all the details of the site. It's still bare bones. And then we have our our floor plan with all the annotations and dimensions and nodes. The same thing over here on our roof. We have a roof plan that tells them where a mechanical zone is, where a roof access ladder is, our cornice is. All this detail gets added afterwards. We have our exterior elevations, which should be popping up. As you can see here on our exterior elevations, we're able to show everything that needs to be added on here to help ease our contractors and tell them specifically what these materials are, what tolerances to follow, and then hopefully reduce the amount of questions and RFIs that we get after we submit for permit. It also helps coordinate with our structural and MEP consultants, because they're able to excuse that, I think I closed the window for a second. We're able to coordinate with them now in 3D and be able to be aware of where things aren't aligning, like a mechanical duct is in the wrong spot, or a column is in the wrong spot, or a structural beam isn't working, or we aren't able to do a thing because of gravity forces. We're able to coordinate that a lot easier versus 2D drawings in the past, which we would have to guesstimate where things were in just by seeing them in plan and visualizing where they would be in a section, I guess, in 3D space. So from all that, we're able to create all these sections, and as you can tell, I could select all this stuff here, filter it, and say I just want to hide all the detail stuff. Actually, let me do it backwards. So this is actually most of what's modeled right here. Everything else is a drawing component that we get to add on top of it. And this is our structural model, which we've loaded in the back to coordinate with them and have them tell us where our top of joist elevation should be. We actually tell them, they just match us. And then from these views here, we're able to create new views where we'll come back in and detail it. Refine the detail, actually, is a better way of putting it. We'll refine the detail to coordinate with the people who will be building this so that they can get it right. Now, I don't want to spend too much time on that because we actually do have to cover how to model most of these things, and I want to be cognizant of your time. So let me go ahead and close all these things. Just give me a second. Close. Nope. Great. So real quick, let me see what's going on. Sweet. Okay. Alright. So for this assignment, it looks like what we have to do is build a 32 by 32 foot long house. And we'll start off by creating a new project. And the easiest way to do that is, we have Revit open. Let's just pretend I already went through and opened the shortcut. And so when you go to open up Revit, this is the first page you'll see. And what you'll do is go select a new project, and the first thing you'll get asked is to pick a template file. Template files are just full of all the information you'll need. They'll have your walls, roofs, floors, and other basic detail and model components that you'll need to help you model your projects. In this case, we don't have any templates loaded because our template files have actually been moved to a separate location. But apart from that, I created a new template file specifically for single family, since our firm doesn't focus on single family. Where I worked previously, we did. And let me find it. There we go. So this is a template file, and I'll run through it really quickly. So what we did is we just created a new project. All the project units and everything should be the way we want it. And what we have here is a start page. This is where you put in all your basic information as if you were actually working at an architecture firm. So that way, in case you fall off the project for some reason or another, somebody else can pick it up. They'll know who the project is for, what's the address, any hiccups. You can coordinate with them by chatting to them through here, and they should be able to see the message and respond to it. And we have all our sheets preloaded in there as well. So let me go to a floor plan view so we can get started. Alright. Alright, so there we go. So this is my current floor plan view. There, it's really empty. A couple of things are hidden. But what I want you to be cognizant of or aware of is these two little things here, the circle and the triangle that keep shrinking the closer I zoom into it. Those are your project and survey points. And basically in 3D space, or if you were to think of your coordinate system, that is your 0, 0, and this would be your y, and this is your x. And of course, jumping from the screen to you is your z axis. Hold on, what's going on? Colt, something wrong? Oh, that's a great question. So the defaults are, yes, they're construction, architecture, and MEP. The best one to use, it depends on what firm you work for. If you work for an MEP engineer, then you would start with an MEP template. If you work for a contractor, you would use a construction or architecture template. And if you work for an architect, you would use architecture. Sorry I didn't cover that. That's a great question. I should have covered, because those are the templates that come out of the box with Revit. The one that I opened is a personal one. They should go ahead and use the architecture one. Is there anything else? Okay. How do All right. So I think that should cover it for templates that you should use. Okay, great. I hope I answered that. My bad. All right. So where was I? So I was talking about the project points and the coordinate system. These are your reference points. They help coordinate with all of your consultants. So whenever you share or exchange models, which still happens, you're basically trading your models back and forth to coordinate how things align, to coordinate your structural grids, your structural columns, floors, roofs, anything of that nature with, let's say, your structural consultant. Your MEP consultant would only be modeling ducts and plumbing and wires. Maybe not even that. That's a whole other level that they may or may not want to get into. But when they're modeling all these things, you'll be able to see the pipes running through your building, all the ductwork. If they're crashing through something that it shouldn't be crashing, then you can point it out and have them fix it. So whenever you reload the model, you should have things as they are working. So that covers that. Let me go ahead and start modeling a floor for our building, which I think is a 32 by 32, and we'll just say that all of these walls are 2x4 wood studs, with some exterior finish, and I'll show you how to build the walls as well. Alright, so let's model a floor. To model a floor, we go up to our architecture tab once we're in the project, and we'll go over to floor. Now in the floor command, everything else is kind of grayed out, and you will mainly be focusing here on this thing to start drawing it. You can start by drawing a line and then carrying it over, so you have a box. Basically the dimensions aren't correct, but if you pick your lines, you'll have these temporary dimensions that should pop up, which you can then adjust. Whichever one you pick is the one that will move. But besides that, you can also draw circular floors. You can draw polygonal floors you can change the sides over here. So let's say we want an 8-sided house. You can draw oval floors. There we go. And you can draw squares and rectangles. Now let me go ahead and delete these. So for our purpose in drawing this house, we'll start from our point down here at the 0, 0, and then carry our floor slab edges this way. So this one is 32, we just want to make sure, and this one is 33, but we'll change it to 32. And there we go. And to finish the command so that you start modeling your floor, you just select the green checkbox, and there we have a floor. We can see it in 3D, and that is what it looks like. Now for let's say you want a different type of floor. You select it and you go to your properties tab over here. And this tab will show you the properties of all the model elements that you will select in Revit. And currently we only have one floor type, which is a 5-inch concrete slab on grade. But let's say we wanted to make it 6 inches. Well, we can do it by, let me do that again. We can do it by selecting it. We hit this edit type button, and then we get this dialog box. And as you can see, it's a system family of floor. Here's the floor we selected, and we have these options to rename it and duplicate it. We'll want to duplicate it, and then we'll name it 6-inch concrete slab. And then go back. We'll edit the structure, which means the thickness and all the other layers of the floor in here. And then we can preview what we're doing in here. So let's say this is a 6-inch concrete slab, and for one reason or another we want to add some carpet on top. Well, we know we'll probably need like maybe 1/2 inch of glue or something, and we can select a material by hitting this little guy in the material column, and then we'll get all these material types in here. I don't know necessarily what kind of glue they need, but let's say it's whatever this material is. This we'll make it up for now. So we have a 1/2 inch of that, and so you can see that over here in our preview box. Well, let's say we also need to show our carpet. That may be another 1/2 inch. And there we go. So we have another 1/2 inch of something. It's not necessarily called carpet yet, but we can create it. And carpet, I do know, is in here, so we can find it. And there it is down there. We'll double click it. If it's down here, you just need to double click it or hit this arrow so that Revit can pull it in from the program files into the project so that you can use it. Then once you've selected it, just hit OK, and there we go, we have carpet. So now we have a 6-inch slab with carpet. And currently the view setting is set to show just a white line, which I think is called hidden lines, and we can change it to be more realistic or show shaded colors. Oh, that was it. Huh. Well, there's hidden line, and this one basically shows you the white background or white objects, and a wireframe view. And then we can also change the settings from fine to coarse to medium. But let me change that back to hidden line. There we go. So we modeled our floor, and it's 32 by 32 as we remember. But now we have to create our walls. And let's say they're 2x4 studs. We'll go back to our floor plan, and then we'll go to the architecture tab, and we'll select a wall. There are many options on how to create a wall. Oh, and there are structural walls as well. We won't focus on these now. We'll only focus on architectural walls. And so as you can see here, for walls we do have a bit more. We have our basic walls, our curtain walls, and our stacked walls. Our basic walls are in the finest, or actually in the shortest terms, they're just basic. They are one layer and one material carried on vertically. Your curtain walls have panels, or have the options to add panels and other model elements like the mullions, the glazing, and anything else you can think of. One thing that I do want to stress is that even though Revit says these things are these things, you can also challenge what you can use certain model elements in place of others to just create something. I know others may find that a little bit how do you say, not the best practice, because then when you want to run material calculations, you end up exporting the wrong data. But in my opinion, we're not doing that, and we also, our contracts, we don't promise that level of detail. You can if you want to. If you want to be super picky about how you want to do it, go for it. And then our stacked walls are a group of basic walls that you can stack on top of each other. You can stack as many as you like. You can go from 2 to 20, and many people use them in, let's say you have a wall that has a stone base and a cap, and then on top of it, which this one should have but doesn't, we'll add it. Oh, it should. Why doesn't it have it? What's the height? There we go. And then it has a basic wall of stucco above it. Now let me delete it. What I did there, actually, because I haven't covered this yet, what I did there was tell the wall in its properties that its base constraint is the first floor, which is this work plane that you see down here, which I will show just now. This is our first floor work plane. And that's our base constraint for this wall, which you can see reflected here. You can change it so that the base constraint is now the top floor. And then it has a base offset, which you can, if you wanted to, offset it, let's say 2 feet from that plane. And no matter how many times you change that level, so let's say this plane is no longer, let me go to an elevation to show that. Let's say that plane hold on, I'm being told I'm a little fast. Colt, do I need to recover anything again? I forgot the lag time. Will do. So let me change this one. Yeah, let's do that. All right, so let's take a step back. We're gonna draw a wall, and we've already chosen the wall. It's already built and assembled the way that we need it. Let me change that back to 0, and I'll change our top constraint to be our top plate. So that means that our wall will stretch from the first floor to the second level, which is our top plate. And what we want to do is we want to draw the wall, but we want to draw it with this edge of the stud line at that edge of the wall, or of the slab. The reason being is because the normal setting for these walls is to draw the wall at a center line. And basically what it did there is draw the wall taking into account the entire width or depth of that wall and giving us its center. So we drew it from its center, versus this wall, which is at the edge of the stud where we need it to be. And this type of face alignment or wall alignment is called the core face exterior, which will draw it at that edge. But let's say we want it to be the interior. Well, that would be the core face interior. Now we've drawn it, but with that edge as our defining line. And we can also do it from the finish face. That did it from the exterior side of the stucco. We normally don't want to do that, especially when it comes to stucco walls, because stucco varies in thicknesses that it really doesn't help. It doesn't help. Hold on, give me a second. Wall placement type exterior face center wall. Colt, let me know whenever you guys are back on. just as he started with the third wall. I don't know what third wall that was. 1, 2, 3 maybe. Okay, so I think I covered the wall alignments. I'll cover just the last one just so that we all know, because there's one more there's a few more that we need to cover. So we covered the wall center line, we covered the finish face exterior, the core face and core face interior. Remember these because I'll run through them a little bit more, how they relate to how you build your wall. So the last two we need to cover is the finish face interior and the core center line. So the core center line is actually the center of your core, which is your core being the assembled part of the wall that is set to be inside the core parameter in something that I'll cover here in a little bit that will make a little bit more sense. But you can also draw it from there. And the last one is the finished face of the interior wall, which is right there. It's drawing the wall from the inside of the gypsum board, and that's okay. Best practice is to model it from the core face exterior or interior, depending on how you work. The reason I say it's the best idea is because normally your structure doesn't change, but your finishes will. So let's say, for instance, your client may want stucco one day, but then the next day he changes his mind and says he wants metal panels. And if you have a couple of walls set to finish face exterior and you change the materials for all those walls, they will flex very differently, and it will annoy you, and it'll create some errors that you may not want. So let's say we drew all these walls. These are interior face. Instead of redrawing them, we can change that by the location line right here. We wanted core face exterior, and there they go. They're both changed. Now let's say we ran into that instance of our client wanting metal panel, but let's change this one to be the center line of the wall. So there we go. That one's center. This one's the exterior core face location line. Now let's edit the type. This is how we build our walls, and we get a preview. Well, we don't normally get a preview, but we can do it by hitting the preview button. And then you'll see we have our named wall here. We can duplicate it, but let's say we want to change this type. Let's say we no longer want the stucco to be 1 inch. And let's say instead of 5/8 of plywood, we want 3/4 inch of plywood. And let's say, for instance, too, we don't want to use 2x6s, which are 5.5. Let's say we're using 2x4s, and those are 3.5. We're using 1/2 inch gypsum board on the inside, 3/4 inch plywood sheathing, and we'll keep that as 1 inch. I don't want to mess with it. We'll hit OK. OK. And you saw how the walls flexed. This one flexed by bringing in the materials towards the edge, the core face exterior edge. This one flexed from the middle, so it brought all those materials inward. They compressed inward rather than change as this one did. So now let's build our wall. Let's say it's that 3/4 inch or that 2.5 inch. Before we do that, let me rename it. It's no longer a 2x6, it's a 2x4. Oh, we have that one. 2x4. Test. Boom. Oh, and just so you know, your wall command is WA. So you don't always have to go up to the button and find it. Now we can make sure that we're going to draw it from our core face exterior by going here. It's going to go up to our top plate level, and then we can start drawing there. And as we pull it, we can see the edge of the stud is going to the edge of that slab, and it's 32 inches by 32 feet by 32 feet by 32 feet. And there we go. And they all joined easily. So normally this is how this house would be built. We have our slab, which then we'll have our footings beside it. And we'll have our studs with only the stud, our walls with only the stud sitting on the slab. And then we may build a second slab edge or a ledge for our finished material, if you choose to do so. It's not typical. Colt, before I continue moving on, are there any questions about walls, location lines? Okay, well then I'll go to level 2. Right here I'm on my second level, and this level is where I'll be drawing our roof. And as you can see, we can't see what we modeled previously below. That's because our work plane is set to show only what we have here, but that's okay because we can go down to our properties window, and that will show that'll show where we that we'll have we'll go to this underlay tab, and we can have that floor plan or view that we're on display the view below it, and so we're able to see what we modeled beneath. Now let's say we want to model a roof. Well, the roof is right here, and same thing, it's still in the architecture tab. Scroll over a couple of buttons and we'll find our roof. And the roofs work similar to floors, where you can draw them in plan. You hit the button, and then you'll go into the command, and this is mainly where you'll be working in the draw tab. And you can do the same things, same commands as the floors. You can draw them by rectangles, circles, polygons, ovals, but really what we want to do is just draw a square roof to match what we have. And then we can offset our line, let's say 2 feet from where we draw. So let's say that's our point of our exterior face of the wall, and we drag it to the other point. And it was smart enough to know that I wanted to draw the line offset 2 feet from that face. So, but you can do it multiple ways, and the command will go away once you get rid of it. But this is what we would have drawn. But this is our 2 foot offset, or 2 foot overhang. But it also has the command to give it an overhang. Okay, so let's see, back to 2 feet. And there we go. Okay, so there we go with the quote. To answer your question, Colt, we don't normally build with generic walls, because if we already know what type of materials are going to go in the project, We don't want to build with something that has no real real materiality. Generic walls are basically like marshmallows. They don't hold any data useful to our consultants that could potentially be wanting to run some structural load calculations, or trying to run a energy model where they can predict how much energy loss or how energy efficient the project is. So all that information is missing from a generic wall. We build with walls and link it to materials that have all that data already included. If you build with a generic wall, you would have to duplicate it and then add all the other information necessary. Generic walls are basically just for, I guess you would use them for conceptual drawings, to be honest, but nothing beyond that, since we're mainly working with real world issues or real world materiality. We model with things that we know are going to go into our projects. I hope that answers your question. Okay, so let me continue on back to roofs. So we've created our square. We have a 2-foot overhang from the walls, and we have these funny looking triangles. Well, these triangles actually define the slope of the roof, and what that means is that Revit is smart enough to create a roof with all of these slopes in it. Currently it's set to 912. Let's just hit OK just so that we can see what it modeled. There it modeled a hip valley roof, and let me change this real quick. One more time. There we go. Well, it's not a hip valley roof, it's more of some weird hut. So now that we have this weird hut, we're able to see that this roof was modeled all to go not at a slope of 912 from the edge over here up to that point. The other walls, the other sides of the rectangle that had that defining element, also went up to that level. And then we can change that here if we wanted to. So if we wanted to go to a 612 roof, you can change it there too. But let's go back to our roof to edit it by going up to Edit Footprint. So we know that this is going to go up 612 and this is going to go up 612. But let's say we don't want it. We want a regular gabled roof. So we select both lines. To select both lines, you just hold down the control button and you see a little plus sign next to your cursor. And that will select both items. And then in order to remove the slope from those lines, you would hit uncheck this box here, the define slope. And once you undo it or uncheck it, you can hit OK, and there you'll see your roof. Your roof is now a gable. There we go. And it's on our second level, our top plate. We can always move it down if we wanted to. Well, actually, we can move it down to meet our walls, but that's not normally how roofs are built, and they normally have rafters. They have some structure. This is just a substrate, and the finished material. So roofs work the same way as walls. We can create them by going to their type and editing the structure. And so now let me insert structure here. And let's say we're using 2x16s, which I would assume it's 2.5. Whoops, no it's not. It's 2x16 is 15.25. Boom. So now we have our roof with our rafters, and it's super basic modeling. You can go back in later and add all this stuff, but for conceptual purposes of this gives you an idea of how the roof would work. And then once you have your roof, you can attach your walls to it by selecting your walls, going up to this modify wall tab, and select the top base, or the top base, attach top base. You can change to attach it to a base or attach it to a top, which in this case would be this roof. Once we know that we're going to select a top, we hit that and the wall will immediately go up to meet the bottom of that roof. And to make it faster, we'll just do these two. Boom. So now we have our generic stucco house. And let's say you also just want to have a different material there. Let's say we want stucco and that type. You can easily change it too. You can change your walls to be different kinds of walls. And this is your the front of your house. Okay, so now that we've covered the roof, now we can cover by adding doors and windows to the project. And say we want an entry door to our house, we would select a door. The same thing applies here when selecting model elements. We have different options of doors to place here. Let's say we want this door here, which is, I don't know, it's a 3'6" wide door by 7'6" tall door. And then you can see that this door is immediately wanting to attach to this wall, and the higher I go is a different level that it will pick. But when we select it, we'll place it either in 3D or go back to our floor plan view and we'll add it there. And the command to bring up the shortcut to bring up your door command is DR. And doors will only be attached to walls. So if you, as you can see, we get that no symbol there, like no smoking or whatever. It doesn't want to attach it anywhere else. There's nothing to host to. It will only host to a wall, and then before placing it, you get a preview of how that door will look. So you can place it here. If you press the space bar, the door may shift side, or since it's on this side of the wall a little bit, it'll change sides of where the swing is. Bring it down a little, it swings in, and it could swing the other way. But let's place it for now. So we have our door, and there's a little bit of issues with the family itself there. We won't worry too much about that right now. We just know that we have a door, and we can see it in 3D. Now we can also do the same thing we did with the wall and change the door type. Maybe we want that type of door as our front door. And if we wanted a different kind of door, by, like, let's say a custom door that we want to make, you can change those things here. So let's say we want a 10-foot tall door for whatever reason. It'll change there. It's 10 feet tall and it's 4 feet wide. There we go. But just remember, as you're doing this, make sure to rename or duplicate your family so that you can organize what you're doing. We still have our 308 or 80 door. Now let's add a window. And here there's a few families that I have preloaded in here. There's a 2x5 window and a 3x5 window. Let's just place a 3x5 window, and we'll do it again in our first floor just so we can have a little bit more control. And the shortcut for the window command is WN. So we select it. It's gonna be 3 feet off the floor, which that's the sill height there. And we've placed our window. Windows act the same way as doors. They will only be placed in walls. So we have our window there. And let's do the command again. So you can also change on which side the pane of the window is going to be. So if you want it inward, which I don't know why you would do, but let's say you did, it would be on that side. This side inward, outward. And there you go. And then we can look at it in 3D. And then we can see there's some issues there. The window is too low and it's cutting our stone weird. And let's say we want it aligned with that top part up there. We just move it up. Maybe it's 3'4". Maybe a little higher. A little lower. They're kind of lined up there. So now we have our windows for our doors. And there we go. Now the other things we have, are interior walls. And those, I'm sure you can model the same way, or you have an idea of how to model them. You just hit WA again. Make sure that all of your settings before you draw a wall are correct. Your location line setting, your bottom constraint, your top constraint, and then you select the right wall. Now, let's say we don't have a 2x4 wall with gyp on both sides. We'll just recreate it here. We'll call this one test just for now. And let's say we have to build it. And here's where these location lines come up again. So we're assembling a new wall here. And what we have is our core here, which is the main structural part of the wall. We can never delete this. We can move it around, but we would have to have something in there. And that is what defines the core face interior and exterior. These would be our finishes, and they can be as thick as you need them to be. For now, we don't need stucco for an interior wall. We do need gypsum board, which is this type of material, and finish down here, and it needs to be the same. It needs to be 1/2 inch. Then we would change this to finish. You don't really have to, but it's recommended for organizational purposes that you do. So now we have our preview of our wall here. They're both it's a 2x4 wall with gyp on both sides. And we can hit OK again, and then we have our wall. And we can start drawing it wherever we need. So there we have our wall. And since we're in a floor plan view, we can add dimensions, and we can change things or make sure that things are the way we need them to be. And when I hit the dimension line, it immediately wants to snap to the center of the wall. You can override this by hitting the tab button and selecting your edge of wall there. You can also view where it's wanting to snap by checking, well, I can't really show you, but at the bottom left corner is where it tells you what it's referencing to snap to. So there, when I hover over the center, it's hovering over the basic wall there. We want this side of the wall here, and it's recommended dimension always to the same side of the wall that you're that you or when you run a dimension string, make sure to dimension the same side of the wall on all the walls except for the exterior. So you would go there, hit tab, select your edge of stud there, and then since we're on the exterior, we would select the exterior side of the wall. But we don't like these dimensions, and our framers wouldn't want to build this. So we can select the wall, and you can see how the dimension string has highlighted blue. It's highlighted blue, and which means that we have the ability to change it. And so we select our wall, and then we can type in a new number here and say that's 17 feet. So now we know we have 17 feet on this side, 15 feet on that side. We can do that with all the walls, as many walls as we need to. We don't have to build it right the first time, but we can always correct it. So same thing, dimension to same side of the wall. You would have to hit tab a couple of times and then just carry your dimension string off to the side. We don't want that dimension. Say we want 9'10". We type it in. Same thing here. 9'10", and we want this to be 7'10". I don't know what these rooms are, but we have them now. And let's say we want to add a door to those as well. We hit DR for our door command, and then just include a new door. And let's say we want the door on this side to be the same offset as that wall. Well, we can mirror it. The mirror command is these two buttons here. This one mirrors by picking an axis, which would be that, or you just pick an axis, or this one you would have to draw your own axis. And the shortcut for that one is DM. But we can mirror that door over there. And we can also copy the same way. That function is located in all of these functions that allow you to modify things are in the modify tab up here. And they are here in the geometry and in the modify tab. So for moving, aligning, copying, offsetting, scaling, all of these functions are in the modify tab. We can mirror by picking an axis, mirror by drawing an axis, we can offset, and also a quick little tip, if you ever get stuck or don't know what a function does, just hover over it for a little bit and a video will pop up telling you what it does. So let's say we want to copy those, and that's this button here, the little circle with two circles. We hit that button, select our objects. Well, you would have to hit that, then just copy. I hit enter, by the way. And there we go. Or the easier way is to select both things and then hit the command for it, which is CO. And that way we have all the doors we need. But we also have this opening here in our door, in our wall. We can do that one of two ways. Let's say we wanted to break this wall up. We would go to the modify tab and use the slice tool, which is, where is it? And there it is, split element, and shows you a little knife, and then you can split these into two separate walls, bring it, and you have your opening. But then when you see it in 3D, that wall is split all the way up, and that's not what you want. So let's go back. And let's undo what we did. We can also load in families for openings. There we go. So we have an opening family here, and it's a model component that will host to your walls as well. And it will create that opening for you without completely destroying your wall. And there we go. So you have an opening and it has a trim. That's just one of many families that you can find online or create yourself. Honestly, if you get to the point where you're creating families, that's actually a good thing, because it allows you more flexibility and creativity to create the types of projects that you want, depending on what your focus is. Then we can add more families by going to the architecture component button, and the shortcut for that is CM. And then here we'll have a list of all the type of families. They include anything from your lighting fixtures, your furniture, so beds, desks, tables, chairs. Trees are also in here as well. People, so they're called entourage. Cars, which sometimes those I think are just called generic models. We have our millwork, our cabinetry, countertops, all in here as well. Shelves, anything you can think of. If it's created by someone out there and you can find it and download it, then you can add it to your project. Let's say we wanted to add this shelf here to our project. And there we go. It's a weird looking shelf. I have no idea why it's doing that. But we can place it in, and if here's another thing, this may go over your head, but if it has parameters, you can change them. So this one, we can change the depth, which means that funky looking depth that it has there, and change that to be 1 foot if we needed to. Let's just hit apply. There we go. It looks even funkier. There we go. We have a decent looking shelf. How to do a slice graphic view. What's a slice graphic view? Give me a second, folks. Oh, a section view. Okay, yeah, sorry. Okay, so now we have the house. Let's say we're satisfied with where it is, and now we want to create other components and create other views. In order to create a section view, which shows you what this house would look like as if we cut it down some point, we would go to our view tab, and there we can find our view options. We can create these different types of views. We can create a 3D view, camera or walkthrough, And section, which is the one that I'll jump into right now, create a callout, which is a little rectangle that will just call out a certain portion of the plan. An elevation, which selects the walls and creates a new view of that. Drafting view, which is a basic view where you can draw almost anything and it doesn't have to be real, but we use them for basic duplicated details that we use all the time. So this section view is actually what we're going to use right here, and it's showing us exactly what it does. It cuts the building by where it's running. Let's bring it to here. And we've already created the view. That's it. Now to access the view, you can double click it, and there we go. We have a section cut through that house. So we're seeing the inside of that house where we modeled it. And we can change the wall or the detail definition of this view to show different stuff. So, to change the detail level actually. So if we want to see it coarse, it looks super basic, but we want to see it fine, so that we can see all the layers and details inside. And here we're cutting through that cased opening. So right here we created that section is cutting, this view is created by this section cutting through there. And then we can change this depth here to show us a little bit more of the house. So if we wanted to see everything beyond in section, all we would need to do is just pull that arrow. And same thing, it's called a building section, which you see up here in your properties tab. And they are used to create your building sections that you would represent on your construction documents. Now, you can also do that in 3D. Well, not really. No, you can't. You can't. It's a yes and no kind of thing. Let's say you want to see a section of this house in 3D. You can't do it by hitting that button that we hit, but there is an option in the properties tab over here, as long as you're in this 3D view. And it's under, it's not in graphics, it's not in extent, well, was it? There it is, in extents. And you just check this box, and you'll get a box around your project. And you can move these, and wherever you move them, as long as it's going through your building, it will create a 3D section view of that. So if you wanted to create, I don't know, if you wanted to show this to a client or use it as an architectural conceptual drawing to show it to somebody, then you can cut your building. You can also hide it, just right click, hide in view and element. The simple command for that is EH, which is element hide. And then to get rid of it and stop it from cutting your building, you can just uncheck this box or pull it away. What is this? But yeah, that's pretty much it for this house and some of the section views. I will go back and through the views one more time, just because there's a couple more to cover, like the call outs. Let's say we want this closet here. Well, we have a blow up of that and only that, and it's at a different scale that we can change here. And the information here will only fill whenever we put it on a sheet, but that's it's not part of the topic today. Main point is once you have all your views that you need, your floor plan, you pull it in onto a sheet and then place it somewhere. The same thing with your section, which most of these are up here. You can pull it onto a sheet here. It'll automatically get this title or view title. And then if you don't want to see these things, you can just hit this button for the crop region to turn on the crop region and then bring it in, and you can hide some of those elements. Some of the elements hide like the elevations because it's cutting right there, and as long as we pass that line, it will disappear. But I hope that helped you guys. Oh wait, there's a ceiling question. Alright, well, since we're in this view, let's create a ceiling. Same thing, let's go to architecture. We have a ceiling button, and then there's one of two ways. Once we select it, and the default is automatic ceiling. If once we hover over a space, it will want to fill that space in with the ceiling. That's going to be 8 foot off the finished floor. We place it. It's not visible in this view because it's too high up. So what we need to do is create a reflected ceiling plan. We don't need that one. We need a reflected ceiling plan of the finished floor. And there we go. We have a reflected ceiling plan with our ceiling that we just created. The second way of creating a ceiling is by sketching it. And let's say we want a little circle ceiling in there. No, not in there, that's a closet. Say we want a circle ceiling in there, and then we want a separate ceiling up there. Where's my sleeping button? Well, there we go. So we have two ceilings overlapping, but we want this one to be higher. Let's say we want this one 10 feet off the ground, and it's out of view. There we go, we got our ceiling and our roof too. And so when we look at this in 3D, we have our ceiling that's at 10 feet, and then we have a little cloud ceiling. And it's pretty much it on modeling ceilings. You have two options. You can fill it in automatically, you don't have to draw a thing, or you can draw whatever you need. You can draw squares, circles, rectangles, ovals, whatever you need to fill in your space. It depends on what you design that would tell you what you need. Is there anything else that you need me to cover? Oh, foundation footing. Okay. Cool. Alright, so we need to add a footing to our slab. Let's select our walls and hide them temporarily. Hit tab. You can select all the walls in a chain command. So you select one, or hit tab, and there you selected them all. Temporarily hide them by hitting HH. And you've turned on this temporary hide isolate visibility option. Now you have your floor, and we want to add a slab edge, a footing, but basically what they're called here is a slab edge. And you would go to the floor command, but instead of hitting it, you hit the drop down arrow, and then you can create your floor slab edge by picking it. And then you would have to create a new profile and a new type that is a little bit more complicated, because you would have to create a family, which I won't be covering right now. But let's say we want to add this 24" by 12" slab edge. There we go. We just pick our line, our edge of slab, and we have our footing. Simple. Since most of these things are already created, it makes our job a lot easier to do this. But if a lot of these elements aren't created, it's a little bit harder, and you would have to hunt and fish out a lot of the content that you would need to model it correctly. Or you can create it yourself. It gets a little inefficient when you have to create everything. Most of the time, first, Revit users coming either out of school or straight out of CAD, just draw everything in the views as detail components, as just detail lines or filled regions, which are filled regions are another way of saying a hatch. So let's say we have our floor slab there. We would create a filled region by going here. We don't want a masking region, and we create it by drawing over our model. It's not a straight line. It's kind of bothering me. There we go. So we have our filled region there. And there we go. It looks just like concrete because it's a hatch pattern fill that shows concrete. And it looks correct in our section, in our view, but model wise it's not super correct. But that's okay, because most of this stuff will have to be covered in our detailed construction documents. Let's see, I don't know what else we would need. Probably fill and sand. Can align this to that. Oh wait, no, I'm in the command. Never mind. You would have to create a separate filled region. And the same thing applies to filled regions. You go over here and you have a multitude of options. Now obviously we don't have plywood, we need sand or something. Or gravel, depending on how you build houses. And then we can also change the scale of this drawing. Normally it's maybe 1/2 inch. And there we go. Is that door still 10 foot? Oh my god. There we go. Alright, so I think that pretty much covers it. If anybody has any questions, I'm still around. Colt's told me, obviously, that you don't have to stay, and I'm sorry if I went like 24 minutes over, so I'm sorry about that. Thank you for watching. But like I said, if you have questions, go ahead and ask. I'll still be on for another couple of minutes. Also, I know I went super fast with that. I can also run through some things maybe just a little bit slower. And also, by the way, if you guys have any question or need anything else, you can also reach out to us on our Facebook page on Revit Workshop. You can also check out my website, rvtworkshop.com. There I'll be building and having a couple of other families, furniture and stuff for people to snag whatever they need. Most of it is, you know, there's not enough content that you need, but hopefully people hopefully people start learning Revit a little better. Um, yeah, and also have a YouTube page. Check that out. I just started streaming and started creating things, so I'll be adding to the list of stuff to create. So thanks again. I'm still on for questions if you guys have any. Alrighty, that's a wrap. Bye everyone. Thank you for joining me, and hopefully that helped you out. If it didn't, let me know. If it did, also let me know. But have a good day.